Hello, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm your host for today's session. And do appreciate your attending today. Everyone in attendance will receive a certificate of attendance that folks use to substantiate their extended education. And especially for today's highly anticipated topic that we will be talking about both changes in the standards and EasyPower's modifications to accommodate that. We will be beginning the session with poll questions. Today's presenter, Dr. Tao Yang, had scheduling conflicts, so he pre-recorded the presentation for us, but I encourage you, one and all, to submit questions in the question section of the control panel, and Dr. Yang will be to answer specific questions. All right, so the first poll question applies to how you deal with your typical projects. It's regarding IEEE 1547, the standard for interconnection and interoperability of distributed energy resources, and also considers IEEE 2800, the standard for interconnection and interoperability of inverter-based resources, and then the IEEE standard 519 for recommended practice and requirements for harmonic control in the electric power system. So regarding those standards, here's what the question is. What typically applies to your projects, your individual projects? So it can be primarily one, some combination of any of the above, or none of them. Again, this is a migrating topic, and the response and the responsibility for updating is of high interest to a lot of us. So it looks like we have a quorum on this. Here's how folks have weighed in. Excellent. Again, appreciate your participation today and responding in kind. The next question is, do you plan to update the studies you've done in IEEE 519 originally in 2014 now that the standard has changed? And again, there's no liability or obligation. It's strictly just understanding the perspective of our audience, and especially if you're involved in this market and you're using EasyPower. So it looks like we're about 5 seconds from a quorum. Good. Here's how folks have responded on this. Interesting. Very interesting. Thank you for participating on that one. And the final poll question is, would you use your own table to calculate individual harmonic distortion? And as you may guess, we're foreboding the presentation that Dr. Yang will be giving us details on. All right, let's leave this open another 10 seconds. Thank you. Here's how folks have weighed in. Interesting, very interesting. Thank you for the feedback. Now, if you will give me just a couple seconds, we will be launching the video presentation. And again, be sure to use the question control box of the webinar controls.
All right, thank you, Jim. Good morning or good afternoon, wherever you are. Welcome to our Thursday webinar. This webinar, we'll be talking about the IEEE 519-2022 Harmonics compliance with EasyPower, specifically with the EasyPower version 11.0 Service Pack 1. My name is Tao Yang, and I'm from EasyPower right now. EasyPower is part of the Bentley system. Very glad that has happened. So during this webinar today, we have three sections to cover. That's what we expect from this webinar. Number one, we're going to review what is new in the IEEE 519-2022 related to EasyPower. Of course, there will be a side-by-side comparison between what is IEEE 519-2014 and what is IEEE 519-2022 with those topics related to EasyPower. For instance, there are many topics in IEEE 519, such as harmonic measurements, right? So those kind of quantities, they are very important, but they are not very relevant to the EasyPower because the EasyPower is a simulation software as a harmonic recording or monitoring equipment, right? So we'll focus on calculation, engineering calculation, planning, operation studies at the corresponding IEEE limits, such as the current distortion limits and voltage distortion limits. Those things are what we care the most from the study we usually do with EasyPower. So that's our focus. The second question we're going to answer here definitely is to provide users about what does EasyPower 11.0 SP1 offer, Service Pack 1 offer. I have to admit that the EasyPower 11.0 without SP1 may have a problem in handling second order harmonics. That's why, one of the reasons we released Service Pack 1, right? And after that, we plan to have this webinar to broadcast and inform our customers, hey, we have fixed the bug. SP1 is available for you to use. Definitely, I checked the program by myself with quality insurance, so I'm confident to bring it to everyone here. So after that, at the very end, I'll show you that as a user, especially advanced user, instead of relying on EasyPower on generating the IEEE 519-2022 report, what can we do as an engineer to build our own report? That's the BYO, usually it's B, right? Now we change to report. So build your own report. In some way, we can see that EasyPower IEEE 519 report is more or less customized to the IEEE 519 standard. But it's not the case for a user because we know IEEE is just IEEE, 519 is just 519. It's not always the case that we engineers would comply with IEEE 519. Some utilities you interact with may have a more stringent requirement than the 519, right? 519 is just a reference. It's just recommended practice. So that's why it's very important for our users to know that how to build our own report to comply with any standards. We have to comply how to build a report in a convenient manner. So we will introduce those three portions. Beginning, of course, let's go back. What new in the IEEE 519-2022? So we put a side-by-side comparison between the IEEE 519-2014 and IEEE 2022. We will see that, okay, looks like the name of the section has been changed from recommended harmonic voltage limit to voltage distortion limit. It's no longer recommended. People feel like it's really just a recommendation of IEEE 519 because by itself it's a recommended practice, right? So it's a redundant, I would say, a description of what is voltage distortion limit. People just take that away, which is, I don't even see that as a change. It's just a wording change, right? What we need to care about the most is that from the IEEE 2022, when you calculate the voltage distortion limit, harmonic order will only be included and limited at 50 Hertz, which means that if you have 51 Hertz, 51st order of harmonic, wherever you are, either 50 Hertz or 60 Hertz as your base frequency, right? Beyond 51 51st harmonic order, it's no longer counted. The voltage distortion is no longer counted in calculating the total harmonic distortion, and also not counted in calculating the individual harmonic distortion. So those limits apply to the harmonic order less than or equal to 50 hertz only. So this limit has been changed in the IEEE 519/2022 to limit the voltage harmonic limit to the 50th order, nothing beyond. So that's a very important change to the voltage distortion. Other than that, everything is the same. That your base voltage at the TCC less than kV is still high, from 1 kV to 69 kV still 3, and so on. And I don't want to repeat those numbers; they pretty much show up over there, right? And of course, the total harmonic distortion VTHD limits does not change as well, so we don't have to worry about that too much. In fact, EasyPower, what EasyPower has done is to only calculate harmonic voltage distortion limits up to 50 hertz. Anything beyond are no longer included in the 519 report. Be careful, we only limit 50th order harmonic voltage distortion in the IEEE 519 report. We would still take them into consideration of calculating the VTHD, calculating the voltage distortion for every harmonics throughout the spectra. We will also display them from the one line. But for IEEE 519, we will only limit to 50. That's the standard compliance we have to do. So that's why some of the users, I think, already have asking this question, hey, why my report does not produce the same result with my one-line display? Well, that's because your report, the IEEE 519 report specifically, can only include harmonic voltage distortion up to the 50th order, right? So that's why it's, again, IEEE 519 compliance. There is nothing new here for the voltage distortion. So that's very simple, right? The next one is current. Now, this gets complicated because you can compare side by side from the left, which is the 519/2014, and the right, which is the 519/2022. That the most important change is that for the harmonic current less than 11th harmonic order, in the 519/2022, the second harmonic order current distortion is included. Because before, people start with the third harmonic, which is a triplet harmonic, right? Because people believe that, oh, okay, the second harmonic order usually is transient or caused by some arc furnace, those kind of things. It's sometimes it's a negative sequence, and sometimes are neglected because it's not steady state. It's just a transient, like such as I would say a transformer inrush or arc furnace. So it's not extremely, I would say, steady state. We all know that harmonics is basically a steady state problem, right? That's why RMS domain power flow can solve it. So starting from 519/2022, the second harmonic order has been included. Is because more and more equipment are introduced in the system which can produce negative sequence, second order harmonic current distortion. So it's included. And also the next item is that for even harmonics, IEEE 519/2014 limits the even harmonics to 25% of the harmonic order of all the harmonic order above across the board. So throughout the spectra, any even harmonic limits, let's say 4th, 6th, right, are limited to the 26th of the all the harmonic limits. So starting from IEEE 519/2022, for harmonic order less or equal than 6, even harmonics are limited to 50% of the harmonic limits shown above in the table, which is, I would say, relieved, right? The stringent has been significantly relieved. And beyond the 6th harmonic order, the even harmonic order and the odd harmonic order limits are identical. So there is no longer, I would say, 25% or 1/4 of the odd harmonic limits applied to the even harmonic limits, right? So that is also a big change, which means that the standard has relieved the even harmonics quite a lot, not only for harmonic order less than 6, but also across the board throughout the spectrum, right? It's no longer 25%, less than 6, less or equal than 6, it's 50% of the odd harmonic order. Higher than 6, it's the same. So it doesn't matter if it's even or odd, right? So it's a big relief. The third one, I believe, is the biggest change between the 519-2014 and the 519-2022, which is the applicability. As you can notice from the footnote, usually footnote contains the most information, right, from these tables, that IEEE 519-2022 specifically saying that the certain IEEE 519 current distortion limits are only applicable to certain situations. Okay, they are limited. The application of the 519 is no longer applied everywhere in the system, such as DER, such as utility scale, inverter-based, or even I would say type 4 wind farm based injection power plants. So in those places, IEEE 519-2022 may no longer be applicable anymore. So that is why in IEEE 519 they have produced the decision tree. People call them a decision tree, that where and when would the IEEE 519 apply. Other than that, what other standards may apply? So we can say that mainly it's introduced by those distribution energy resource and all inverter-based resource, which usually we call them as utility scale. DER is the distribution level, community, things like that. Sometimes community can be inverter-based resource as well, right? Community solar, those kind of power plants. So we're gonna have to ask a question before we get started, that if IEEE 519 current limits is still applicable across the board, or should I select some other standards such as IEEE 1547, which applies to the DER, right? And also the IEEE standard 2800, which applies to the inverter-based resource, usually utility scale, right? So depends on the penetration level of the renewable generation, especially inverter-based resource generation. Sometimes the IEEE 519 may no longer be applicable. The IEEE 519 mainly would apply load side, right, instead of the generation side. So be careful about if that is the place, if the right standard should be applied at the place that you take your harmonic measurements, or you construct your power plant model, or you construct your industrial plant model, not power plant, but just industrial plant model. And how many DERs are there? How many inverter-based resources are there? Do you still consider that your combined cycle rated generation is exceeding 10% of your annual average load demand? If yes, then it's still under the IEEE 519. If the answer is no, probably because of the significant generation you have in your site, you will have to find another standard to comply with instead of IEEE 519, right? So this decision tree basically tells us that before you apply the IEEE 519 current limits, think about it, what percentage of the site rated generation are there in your plant. For instance, in your renewable generation power plant utility scale, let's say 100 megawatts of generation sites, right? Definitely the total rated generation is over 10%, not only 10%, it may be 100% or 200%, 300% by annual average load demand, right? So on the other hand side, the IEEE 2800 would be applied, or if you have a DER or enough DER in your site, in your industrial plant sites, if the penetration level is 10%, probably consider IEEE 1547. That's the standard you have to comply with. Also, talk about that with the utility that you connect to and say what exactly standard should be applicable here. Maybe none of them, right? Again, those IEEE standard, just IEEE standard. At the very end of the day, they are just a reference used. So the utility and your site can achieve a mutual agreement about what limits should be there. So that is the main change I would say applied to the IEEE 519-2022, which means that we have to think that if IEEE 519 is still applicable or not. So that is my takeaway of the major changes we have had in the IEEE 519-2022. Of course, we know that the current distortion limits are voltage level based, right? So you cannot say, hey, I only want to change one table with ignoring all my higher voltage and others. For instance, the table we just showed now applies to 120 volts to 69 kV, which is mainly, you say, our low voltage level or medium voltage level power plant sites, not power plant, but maybe industrial plant sites, right? Depends on what's your loading level and what's your generation level for your sites. So going forward, we have also 69 kV to 161 kV, right? You can see that it's the same. The harmonic order now includes the second, and also the harmonic limits have been changed. Before it was 24% of the even of the all harmonic limits. Now only less or equal than 6. It's 50% even harmonics of the all harmonics. Going above 6%, even the all harmonics limits are identical, are the same, right? And also applicability even for the high voltage sites. I would say this specifically applies to many renewable power plant, inverter-based renewable power plant, right? Same story applied to 160 and above. No, here is a 160 kV above, not and above, because and above was covered in the previous table, right? So be careful about the applicability. But again, everything included here about the voltage level are automatically incorporated in EasyPower code. We don't have to worry too much about it. As a user, we do have to configure the PCC load demand and short circuit ratio to see which list from the table, which row from the table we should pick as the IEEE limit applied to the current distortion, right? But the voltage has been determined by the PCC breaker, which has been placed at, right, the bus voltage. So those are pretty much the changes we have seen related to EasyPower, which are IEEE 519/2022 voltage distortion limits and current distortion limits. Now, what does EasyPower 11.0 SP1 offer? Be very specific. Again, I apologize for some bugs we introduced EasyPower 11. That's why we postponed this webinar, and that's why we have this service pack released pretty soon after 11.0 release, because our 11.0, I believe most of our users know that our 11.0 is mainly about unbalanced power flow, which is a huge piece of the development for EasyPower, and now our EasyPower user can utilize unbalanced power flow to solve their unbalanced network, right? So it's no longer grid out. Remember, our single phase system, as we introduced in 10.4, are all grid out in power flow. It's no longer grid out. It's applicable 100% in 11.0. But unfortunately, we introduced a bug in the IEEE 519/2022 calculations, which has been included in the release notes as well. So we fixed that immediately. I found it last time when I was about to prepare this webinar. Sorry about that again. So be careful to use EasyPower 11.0 Service Pack 1. Specifically, if you launch your EasyPower 11, you should be looking at your version is equal or larger than 11.0.1 ATS39, right? Your subversion 11.0.1 ATS39. Make sure your EasyPower version is later than that. The bug was introduced because the second harmonic order was not taken into consideration somehow, and I found out and immediately put out a service pack when I prepared the material. By the way, I will also show you how I found the bug, which is to customize our own report, right? You don't have to 100% rely on EasyPower. You can rely on your engineering judgment about how to construct the report, but make sure that they definitely match. So you gain confidence that EasyPower is giving you the right result after 11.0 Service Pack 1, right? So that's a note we have to make over there. We will use a very simple example case here. As you can see, it's a 4-bus system, right? With 2 loads, 2 VFDs, and some reactive compensation or power factor correction equipment, and also the utility system. We will switch to EasyPower later on after we introduce what this is, and then show how could we see the IEEE 519 report if we have the second order harmonics in my system. Definitely, first thing first is that we have to show how to model it, right? How to model my second order harmonics into the system. And then we will show that what is the difference in the EasyPower reports before and after the introduction of the second order, right? If you have interest, you can do the same thing, that construct your own system in EasyPower 10.6, right? and then construct your system with a load which includes the second harmonic order current injection, run it, see the IEEE 519 report looks like, because in the 10.6 and the prior version, the IEEE 519 report was based on IEEE 519 2014, starting from EasyPower 11.0 Service Pack 1. All standards are, not all, I mean, the IEEE 519 standard are converted to the 2022 standard limits. If some of the customers would still like to go with the 519 2014, we will show you how to construct a report by yourself, so you can customize it. Definitely, we will include that option of swapping between the 2022 and the 2014 standards in the future, because many customers has already been asking, hey, I still want to 2014 report. Okay, we will do that in our later release. So, but at the same time, I will show you how to generate a report by yourself. Definitely, it's the same thing as what EasyPower generates for you. Example case, yeah, second harmonic order. This is what we're going to show you how to model it. It's basically get into the load, just put a 2 as the second harmonic order, and put whatever harmonic current percentage of the magnitude it is, right? It's very straightforward, as we usually do, to model the fixed and search any harmonic order of a load. And then you model your PCC with the point of common coupling breaker and enable the IEEE 519 point of common coupling checkbox. Enter your kVA demand. We will show again how to calculate your kVA demand. Of course, this kVA demand from EasyPower may not always be the kVA demand you want to enter over there, because from EasyPower, especially in my example, it's consistent. But in many cases, because we have a lot of scaling across the board in power flow going on, people will say, you know what, at a particular load flow scenario, let's say I'm only having 90% of my load modeled, but actually throughout my year average or largest, sorry, here is largest load demand is slightly higher than that. That's okay. That's why we allow you, the user, to enter this value by yourself, because you know the system better than we do. So it's a convention we keep following, that the user enter the kVA demand. In my case, it's not always the same, just a reminder, right? And also enter the short circuit ratio, which is a system strength as a requirement of the IEEE 519, because you need to tell EasyPower out of the current limit table which row to choose, right? So that's a typical setup of the PCC breaker. There is no change over there. Again, the only change EasyPower has to comply with the IEEE 519 2022 is to change the limit lookup table and change the outputs or the report format. That's all. And because you enter the short circuit ratio, and because we know the PCC voltage from wherever it connects to, right? So EasyPower will look up the right row for you, as we mentioned just now, right? Take a look at the system. What do we have for the system? The bus voltage here, right? The PCC bus voltage is 0.48 kV, which is 480 volts. So definitely it falls into the category of 120 to 69 kV, right? So because we already know that my short circuit ratio is 12, so I know that, oh, okay, because my short circuit ratio is less than 20, so I have to choose the first row as my current distortion limit, and also my total distortion distortion limit, right? So that is how we EasyPower choose the right limits to use here, and that's the expected IEEE 510 limits. So see from the report. And after that, once you finish up the modeling and go to the harmonic study focus, this is where you pick, okay, I'm gonna enable my IEEE 519 2022 limit check in my summary report, right? It's just a summary included in the summary report. You have to pick it, you have to choose it, right? So after we are done with all those steps, okay, from the report, we will show that how EasyPower will populate the new report and how the report looks like. Basically, it looks like right in front, right? We will only check, you know what, for the IEEE limits, harmonic order should be less than 50%, all right? That's pretty much the cutoff. If we go beyond 50, we may not have them show up over there, because that's IEEE limits defined that only have the 50th order of the harmonic current injection, right? And for even harmonics, if the harmonics order is less or equal to 6, we will have it as half, let's say 50% of the harmonics, right? Other than that, you can say 7 to 10, 11 to 16, 17 to 22 onwards, they are identical, right? Which is what IEEE 519 required. And there is no longer odd or even harmonic total distortion show up in the table because there is only one limit. There is no such a thing of differentiate between those two of them, right? So that's pretty much it. The report looks like in EasyPower 11.0 SP1 after you enable the IEEE 519 reports and after EasyPower get the report to you. And the voltage is the same. I don't think there is any significant difference. Again, IEEE limits only apply to harmonic order less or equal to 50th order harmonics, right? Anything beyond it, they will still be calculated in EasyPower. They will still show up in the EasyPower 1 line, but they will not show up in the IEEE 519 report. They will still exist in the Spectra reports, right? If you are comfortable with using Spectra, feel free to use it. But as a summary, they won't show up in the IEEE 519 222 report. That's a requirement of the IEEE 519. It's a compliance. So that's why it's only included with up to the 50th order. And we do put the extra harmonic order less or equal than 50 over there applied to the IEEE limits to remind our user, hey, only harmonic order less or equal than 50 are included. To look at the one-line display, you may find something different than this number, 10.4 over there, right? If you have the 51, 52, any harmonic order higher than 50, well, that's not included in the summary report of IEEE 519-2022. You still can see it from the one line. You can still see it from the Spectra reports. IEEE EasyPower will still take that into account in calculation. It's just not show up in the IEEE 519-2022 report. That's all. So that's pretty much the presentation slides. Again, I don't want to stick with the presentation slides throughout the whole session because afterwards we want to demo it to show how EasyPower works, right? So let's just switch from the presentation slides to EasyPower. I actually have the case show up in front of me, but I just want to start from scratch and then to show that how to construct this case. I'm not gonna save any changes here. So let's launch EasyPower. EasyPower 11. Again, make sure your version is larger than 1839, right? Which is SP1. So I do have my webinar example case in front of me right now. So let's open it. It is the same as we introduced just now from the slide that I have two VFD loads, power factor correction cap bank, right? As my utility. Now, if I click on one of my VFD loads, it has a harmonic tap. So definitely this is based on 5,000 as a fundamental current, right? And also I have my harmonic number as only 5th and 7th harmonic currents. And my percentage is 20% of each, right? Now, the reason I have my fundamental currents over here is because I want to say, okay, either I choose my equipment rating or user specified. Putting it as 5,000 would specify that what my load demand current is, right? What you can do is put it back over there. Let's say, 5,500. It's not a big deal, but I just want to put a 5,000 over there for me to calculate my current demand properly based on my harmonic current. So every harmonic current will be based on the 5,000 instead of the load current, right? So that will help me calculate, okay, what is exactly my harmonic current, because everything is based on the fundamental, right? So 20% multiplied by 5,000, that's very easy. 1,000, right? 1,000 ampere of the 5th harmonic order current injection, and same thing applied to the 7th. That's one of the loads. Another load, we will introduce another load as that adding a second order harmonic with 40%, which is large. It's incredibly large because I just want to show you an example that if you have a current load like this, now harmonic current demand like this, how will that affect your IEEE 598 report? Usually we don't have that high percentage of second harmonic order, right? So we just want to show you an example. Again, I use the user specified current over there for me to easily calculate if I have to, what's my current injection. So when I debug the program, I know that, oh, okay, number I'm expecting, you will give me either right or wrong number, right? Okay, so this is a system configuration. Again, two VFDs, one with second order harmonic current injection, another one without it. So those are my two load, and I have two branches for sure, right? And another branch, which is a transmission line to connect my site to the utility system. Of course, I define my point of common coupling breaker at the point of interconnection here, right? So if I put my PCC, okay, I know that I have to model it as a 519 point of common coupling. How do I get my kVA demand? How do I get my ISC versus over I load? It's very simple, right? I believe many of our users know already that go to power flow, solve it. The current you have over there, make sure this is current is display. Okay, my branch flow is current in amperes. So my I load is 1019.688, right? Now I know my I load. Go to short circuit. Run short circuit, apply three-phase ground fault. Okay, my fault current is 120 kiloampere. So 120 kiloampere divided by 10 kiloampere of the I load, which is we saw just now, right? Take a snapshot. Snipping tool. Snip it. This is my fault current, right? I short circuit. Now go to power flow, click on solve. Okay, my load current is 10 kA, right? It's 10019, so which means that it's 10 kA approximately, right? So use my ISC divided by I load, which will give me 12. That's why we model the breaker PCC ISC divided by I load equal to 12, right? kVA demand, very simple as well. Again, to my example, it's very simple, but to your power plant or to your plant, it's now not always simple because the load flow does not always give you the kVA demand. You gotta have to think about what's your worst case largest load demand in your system throughout the year. That's what you need to enter over there, right? So for my example, I just choose, I want to display the kVA power factor. Okay, my total kVA is 8330 kVA. That is why I entered my harmonic kVA demand at 8330 to tell the program what is the fundamental current to be used when I calculate my current distortion, right? So those are the quantities we needed. Now we're done with modeling the harmonic current injection. We're done with modeling the PCC with specification about how to calculate the current and also the limits, right? Now let's go to harmonics. Just easily make sure that harmonic options, you have included your, sometimes I like to include my summation spectral report because I always like to compare my spectral report with my summary report to make sure that, okay, EasyPower is giving me the right solution, right? I definitely believe it now in the service pack 1, but feel free to check by yourself. Let us know if you find otherwise. We can also explain why it is calculating that way, how to interpret the spectral report, right? We'll touch a little bit today, but maybe not in full. Okay, so click on OK. Solve again, click on summary. Now let's go back to the result, okay? This is the summation summary report, which includes IEEE 519. So you can see that, oh, because I have introduced fifth and the second, right, between the 2 to 6. I have introduced fifth order and the second order. Now the maximum all harmonics I received is the 1986. And the even harmonic current distortion I got is 29.35. For sure, this is the second harmonics, right? For sure, this is the fifth harmonics because that's all I have, right? From 2 to 6. The second harmonic current distortion comes from this bit. right? The fixed, because I have both VFD included the fixed harmonic order, so it's a combination of both VFDs, right? And then I have 1/7, so definitely 6.82 comes from my 7th. So that's why I have my 2 to 6 have 2 violations, and 7 to 10 has 1 violation, right? Of course, I follow the same equation to calculate my ITDD, and follow the same way of calculating the ITD as well, to include every one of them, right? So in that case, I have my maximum voltage as well. We will take a look at about where it is, and what's the VTHD as well. You can see that right now VTHD here 10.4 is equal to 10.4 here, right? Because we did not include any of the harmonic order larger than 50. Now let's try to introduce some problem here for people like even like me, having a difficulty saying that why it's different. Oh, wait a second, it's about 519 2022. It's a summary, it's not everything, right? So let's put 15.1 over there, because I know that my system is very strong, so I'm gonna have to put let's say how about 80, right? 80% of the high order harmonic current. Click on OK, and then I go to harmonics again, click on summary. Now you can see that, okay, my voltage distortion show up on the one line display goes to 10.432%. If I bring up my summary, IEEE 519 table, I still have my 10.4, right? So the VTHD here is no longer equal to what I have displayed on the one line. This is because from the one line, we display everything, right? That's whatever you comes in, we will display it out. Easy per tip, I don't need thank you here. But from the IEEE 519 summary, that's supposed to only include harmonic current and voltage distortion up to 50th order, right? So that is why sometimes it's different. Again, we put the IEEE limit H less or equal than 50 over there as a reminder for a user. So that's pretty much it for the EasyPower 519 2022 compliance. Again, feel free to use it. Let us know if you think there is a problem, or you think you want to recommend a different way to do it. We will take a look. But that's so far I would say the copy and paste way of the 519 report if you follow that, right? The last thing today, definitely comes to the most interesting part, is to validate. Does EasyPower really produce me the right results, right? We know that I have my spectral reports here. I know that from the harmonics module engine, it can speed out the harmonic current flow everywhere, right? On my transmission line, on my cable, etc. So I know that my PCC breaker is defined on my transmission line X1, right? This is X1, right? If you put your cursor on it, stay around, it will show up with X1, and just right click DB info, it will show you, okay, it's ID X1, it's a transmission line. So I know that, okay, out of my report, the transmission line name X1 shows me what is my current flow on this line specifically. How do I do a side-by-side comparison by calculating the harmonic limit violation table by myself as an engineer and compare that with EasyPower to gain confidence that EasyPower is doing the right thing, right? Oh, okay. What I do, very simple, right? I will just convert or export this table to Excel. Find out, okay, this is my transmission line, right? It's the same thing here. 2940 seconds, 1990, 683 sevenths, and I have a 51st order, 1929. Okay, how do I calculate what is my current distortion in percentage here? Right, definitely it's this number divided by some fundamental, and we know that fundamental current is not 1,000. What is 1,000? Where is this 1,000 coming from? Right click the transmission line, click on DB info. Rating is equal to 1,000. This is 1,000 comes from. right? Because in your harmonic options, the control option is to honor summation fundamental VI as user-defined 1 per unit voltage, which means that we comply with the nominal rating and nominal per unit voltage across the board. That's why the transmission line rating is used as a fundamental. But to calculate our limits, we cannot use that number, right? We have to use our load demand that we know. Where is my load demand? My load demand is what I entered over here, right? 8330 kVA. What's my voltage? My voltage is 0.48. Okay, you got your kVA, you got your voltage. Then you calculate your load current based on that, right? It's actually calculated. We just saw that from power flow already. So I'll just make it simple. That kVA demand is equal to, let's put it here. kVA demand is equal to 8330. My kV is equal to 0.48. Then my I fundamental, right, is equal to kVA divided by voltage. Is that it? Square root of 3, right? Keep in mind, power system 101 thing, right? Okay, this is my load current. It's not 1,000. It's actually 10,000, right? Now I know that, oh, okay, my current distortion at the second order is going to be my ampere observed divided by the fundamental. Okay, I need to make it as S4, make sure that when I play around with the equation, they won't change, right? I want to say it in percentage, so definitely I need to format my cell to percentage. Second, the 2 digits after decimal is fine. Drag it down. That's my second order harmonic current distortion. This is my 5th order harmonic current distortion. I keep this and I compare with my summary table, right? I know that my second order is 29.35 based on my hand calculation. Even harmonics within the range. That is the second harmonic order, right? 5th is 1986. 1986. 7th is 6.82. 6.82. 51st. Oops, I don't have it because the IEEE 519 limits at 50, right? So I don't have it anymore, but I can still calculate if necessary. So this is the way that the engineers can build your report. Same story applies to voltage. If I want to go to voltage, I should have it above here. What's my bus? My bus is bus 2, right? Where the PCC is connected to. Not bus 3, because bus PCC is on the bus 2 side of the transmission line, right? So it should go to bus 2. So what I need to do is to go to my bus 2. This is my bus 2 voltage table. It's actually much easier over here because we honor the 1 per unit. It's just a format this table, right click, format cell as percentage. That's it, 8.27. That's the largest, I would say, the voltage distortion. What's my result? 8.273, right? And the VTHD, I don't want to calculate anymore. If you have interest, feel free to use the which is square root of them, sum them up, and get the square of them, sum them up, and get the square roots. That will give you the 10.4. Feel free to check by yourself. Again, we may have limited time over there today, but definitely we have checked that offline. So when we do the quality assurance, right? That's pretty much it for the IEEE 519 2022 compliance in EasyPower. Let's go back to the webinar slides. Again, I didn't go through every slides that I have prepared over there. I believe the slides are used to refresh yourself. If you want to review the webinar again, or just want to spend some time reviewing the slides to show, okay, how do we get there? So I won't be playing those slides because we have already showed them on EasyPower step by step about how EasyPower complies with IEEE 519/2022, and as an engineer, how do you calculate the any IEEE reports as you need it based on the spectra report of the current voltage, right? I think that's pretty much it for today. Thank you very much. This is Tao. Oh, what's expected? Here we go. So selection between the 519 and the 2014 and 2022 is what's gonna be in our development roadmap. We definitely hear our customers saying that, hey, I want to still stick to my old standard, because IEEE 519 is not a code, it's just a recommended practice, right? Some utility may still stick to the old one if it is applicable. And some customers already have been asking, hey, when you will start supporting 2800? It's really not a big change of the result. We just need to design the product and to show how we comply with that. It's just a different set of limits. There is nothing changed in harmonic current calculation. We just need to apply the limits properly to the table. Of course, we need to think about what quantities the user can enter, like what we do for the hand calculation, right? It's the same thing to the 1457. So stay tuned. Those future development are under to support more applications of the EasyPower Harmonics module in different situations. But at the same time, we already show you, if you got your specific requirements, how to generate your own report by yourself, right? So feel free to use that as well. As a matter of fact, for some projects I do for my customer with using EasyPower, for EasyPower customer, they actually don't like this report. They were saying that, how do I know where this individual harmonic current violation comes from? Where should I troubleshoot my system, right, etc. So from the summary report, we still need to go to the detailed spectra and find out, okay, which one exactly is the harmonic order that having these violations. Then we will do a frequency scan, we will do the single flow or all source flow to find out where the weak spot of the system is, who is the culprit, and how to fix it, etc. So being able to customize the reports, limit violation report as an engineer is going to be a big help. As I just showed you, is actually very straightforward. Once you have the spectra, current, and the voltage results, how to customize it. I believe, Jim, all those examples and the final example spreadsheet will be available after the webinar as usual. So feel free to reach out if you have any questions. Thank you very much. Again, this is Tao from EasyPower. If you have interest, please feel free to try a demo of the EasyPower software from EasyPower.
So that completes our presentation for today. I very much appreciate your attending, and you're more than welcome to contact Tao if you have questions. EasyPower values your support. Thank you very much.